Math 148, Chapter 11. 11.1 is derivatives of logarithmic functions. 11.2 is derivative of exponential function. And 11.3 is implicit differentiation. So let's first start off with some log review for 11.1. Logarithmic functions. For a greater than 0 and a not equal to 1, the logarithmic function y equals log base a of x is the log form, has domain x greater than 0 and base a, and is defined by a to the y equals x in exponential form. So principle of exponential equality. For any real number a where a is not equal to negative 1, 0, or 1, a to the x equals a to the y provided x equals y. Or if you have x equals y, then this is also true. That's what these double arrows mean. Now we have something similar for logarithms. For any real number a greater than 0, a not equal to 1, and for xy greater than 0, then the log base a of x equals the log base a of y means that x equals y, or if you have x equals y, then you can take the log base a of each side. Other log properties we need. A to the log base a of y is just y, log base a of a to the x is x, and log base a of 1 equals 0. Power rule. For any positive number n and real number a greater than 0 with a not equal to 1, and any real number p, if I have log base a of m to the p, that exponent becomes a coefficient. That becomes p times log base a of m. The product rule. If I have the log of a product, that is the sum of the individual logs. So log base a of mn equals the log base a of m plus log base a of n. And the quotient rule is if I have the log of a quotient, it becomes the difference. So the log base a of m minus the log base a of n. So we need these because it makes finding a derivative much, much easier if we have the logarithm simplified. So to find derivatives of logarithmic functions. So the derivative of y equals the natural log of x. So then y equals the natural log of x, y prime equals dy dx equals 1 over x. So for this first one, that would mean I'd have 2x cubed becomes 6x squared minus 1 over x. So let's find y here, but rewrite it first. So y equals the natural log of x plus 2 to the 2/3 power. Now I'm going to use the power rule to have that come out front. So y equals 2/3 x natural log of x plus 2. So y prime would equal 2/3, nothing changed there, times 1 over x plus 2. So that's going to simplify as 2 over 3 x plus 2. So now this next one is a little bit different. Because notice this is on the outside of the logarithm. So this is going to become y equals the natural log of x plus 2 to the 2/3 power. So y prime becomes 2/3, chain rule, x plus 2, subtract 1 becomes negative 1/3, times the derivative of what's inside, which is 1 over x plus 2. So simplifying this, we could have 2 in the numerator, 3 natural log of x plus 2 to the 1/3, and then we'd have x plus 2 there. So now what happens if we have the natural log of u, where u is a differentiable function. Notice we do have that here, but the derivative of x is 1, so we don't have to deal with it. So what we end up having is, when we want to take the derivative of the natural log of u, we get 1 over u du dx, which is u prime of x. So we end up having 1 over u times the derivative of whatever is in the log function. So let's take a look at example 4 here. So the first thing I'm going to do is I'm going to use my log properties, because I notice I have an m times n here. So this can be y equals the natural log of x squared plus the natural log of x cubed minus 8. So I'm going to use my exponent rule of logarithms, or the power rule, 2 natural log of x plus natural log of x cubed minus 8. Now to take the derivative, I have the 2, 1 over x, and chain rule is just 1, plus 1 over x cubed minus 8 times 3x squared. So that's 2 over x plus 3x squared over x cubed minus 8. So let's take a look at this next one here. So f of x equals 3 plus 10 natural log of x to the 4th minus 3. So f prime of x, well, that goes to 0 because it's a constant. So this is 10. That'd be 1 over x to the 4th minus 3 times 4x cubed, using the chain rule. 10 times 4 is 40x cubed over x to the 4th minus 3. So I would like you to try this one. So pause the video. You're going to end up having the power rule and then the difference quotient there before you actually take the derivative. Okay, so hopefully you're back and you've tried it by yourself. So f of x equals 1/2 natural log of 5x minus 3 over x cubed plus 1, which is 1/2 natural log of 5x minus 3 minus 1/2 natural log of x cubed plus 1. Now taking the derivative of this, f prime of x, 1/2, well, that would be 1 over 5x minus 3. Chain rule gives me a 5. Minus 1/2. That would be 1 over x cubed plus 1. Chain rule gives me 3x squared. So this is going to give me 5 over 2 5x minus 3 minus 3x squared over 2 x cubed plus 1. Okay, try this one. Okay, hopefully you've paused it and tried it. So y equals 3 natural log of x squared plus 4x plus 1. So y prime equals 3, 1 over x squared plus 4x plus 1. Oops, a little too big. And then the chain rule is 2x plus 4. So if I multiply that, I would get 6x plus 12 over x squared plus 4x plus 1. Okay, again, try this one. So this one, you're going to get y prime equals 3 natural log of x squared plus 4x plus 1 squared times the derivative of this, which is 1 over x squared plus 4x plus 1, times the derivative of the denominator, which is 2x plus 4. So this one is going to be 6x plus 12. Then I would have the natural log of x squared plus 4x plus 1 squared all over x squared plus 4x plus 1.